Hey everyone, and welcome back to the channel. Today, we're diving into some massive news that connects a surprising comet, our hyperactive sun, and what it all means for us here on Earth. This is a story you'll want to stay tuned for, because things are about to get very interesting in our cosmic neighborhood. So, let's start with the comet. Its name is 3IATLAS. Now, this isn't just any comet. It's an interstellar visitor, meaning it originated from outside our solar system. Astronomers have been tracking it, and it's expected to make its closest approach to the Sun, or Perihelion, on October 29, 2025. But here's where it gets wild. Recently, while the comet was on the far side of the Sun from our perspective, it suddenly and dramatically brightened, far beyond what any of our scientific models predicted. Naturally, the first question was, what happened? The Sun has been incredibly active lately, firing off powerful explosions called coronal mass ejections, or CMEs, from its far side. Did one of these CMEs hit the comet and cause it to fragment or change course? This was a major concern. If it had been knocked off its path, all our predictions for its journey would be out the window. To figure this out, scientists used coronagraphs. These are special telescopes that block out the Sun's intense glare, allowing us to see the much fainter objects around it. By stacking these images, they created a clear view of the comet's path. The verdict? Comet 3IATLAS held its course perfectly. It didn't deviate one bit. So, even though it was likely hit by a wave of solar particles, this tough little interstellar traveler is still right on track. The light curve, which is basically a graph of the comet's brightness over time, tells a fascinating story. It shows this huge, sharp spike in brightness right when the CMEs were happening, and then it started to settle back down. This suggests the blast from the Sun didn't break it apart, but instead caused a massive release of gas and dust from its surface, making it temporarily shine like a beacon. It's an incredible display of cause and effect on a cosmic scale. But the story doesn't end with the comet. In fact, this is where it gets even more relevant for all of us. The source of those powerful CMEs, a group of hyperactive sunspots, is now rotating into view, directly facing Earth. And this is a very big deal. These sunspots are crackling with magnetic energy, and they have the potential to unleash significant solar storms aimed directly at us. We're talking about the possibility of G-level geomagnetic storms. And G stands for geomagnetic, and the scale goes from G1, which is minor, all the way up to G5, which is extreme. These powerful storms can have some serious impacts on our planet and our technology. So, what does this mean in practical terms? Let's break it down into a simple data versus impact timeline. First, the data. Over the next few days, we'll be watching these sunspots very closely. Solar observatories will monitor them for solar flares, which are intense bursts of radiation. If a large flare occurs, that's our first warning sign. The light from the flare reaches us in about 8 minutes. The next piece of data is the CME itself. If a flare is big enough, it can launch a massive cloud of charged particles into space. Satellites like the SOHO and Stereo spacecraft will see this cloud leaving the Sun. Based on its speed and direction, scientists can forecast if it will hit Earth and when. This usually gives us a lead time of about 1 to 3 days. Now let's talk about the impact. When that CME arrives and slams into Earth's magnetic field, the real effects begin. One of the most beautiful impacts is the Aurora, the northern and southern lights. A strong storm could push the Aurora far south of its usual Arctic home. People in the northern United States, the UK, and even further south might get a chance to see the sky light up with dancing colors. This is the spectacular positive side of a solar storm. But there are also significant challenges. The influx of energy can cause satellite drag. It heats up and expands our upper atmosphere, creating more friction for satellites in low Earth orbit. This can cause them to lose altitude and require course corrections. For satellite operators, this is a major operational headache. Think about Starlink and other satellite constellations. They all become more vulnerable. Then there's our communication and navigation systems. Geomagnetic storms can disrupt high-frequency HF radio communications, which are used by airlines, emergency services, and maritime shipping. They can also interfere with global navigation satellite systems, like GPS. Your GPS might become less accurate or even temporarily unavailable during a strong storm. For anyone relying on precise positioning, from agriculture to aviation, this is a serious issue. And finally, there's the power grid. A truly extreme G5 storm, though rare, could induce electrical currents in long-distance power lines, potentially overloading transformers and causing widespread blackouts. This is the worst-case scenario that grid operators prepare for. So, what can you do to prepare right now? First, don't panic. Don't. The most likely scenario is some beautiful aurora and minor technological glitches. But it's always good to be ready. Have a basic emergency kit with water, non-perishable food, flashlights, and a battery-powered or hand-crank radio. Make sure your phones and power banks are charged up. It's the same simple preparedness you'd have for a severe weather storm. If you're a drone pilot, an amateur radio operator, or rely on precise GPS, be extra aware of space weather forecasts over the next week. You can check websites like NOAA's Space Weather Prediction Center for real-time updates. Now, let's circle back to Comet 3IATLAS. With the immediate drama over, what's next for our interstellar visitor? Its journey continues toward that 2025 Perihelion. Because it survived this solar blast, it's a great sign that it might just put on a fantastic show for us. Astronomers will be watching it intently as it gets closer. How can you observe it? Right now, it's still very faint and requires a decent-sized telescope and dark skies. But as we get into 2025, it should brighten significantly. Keep an eye on astronomy websites and apps for its position and predicted brightness. It could potentially become visible with binoculars or even the naked eye as it makes its closest approach to the Sun and then to Earth. We'll definitely be doing follow-up videos as that time gets closer, giving you finder charts and tips on how to see it. This event, this sudden brightening, has made Comet 3IATLAS an even more exciting object to watch. It's a survivor, and it has a story to tell. So, to recap, an interstellar comet had a dramatic, unexpected flare-up thanks to our hyperactive sun. It survived and is still on course. The sunspots responsible are now turning to face us, meaning we need to be prepared for potential geomagnetic storms in the coming days. This could bring stunning auroras, but also pose risks to our technology. It's a perfect example of how dynamic and interconnected our solar system is. Events happening millions of miles away can have real, tangible effects right here at home. It's a powerful reminder that we live in a cosmic shooting gallery, but also a place of incredible beauty and wonder. What do you think? Are you excited about the possibility of seeing the aurora further south? Or are you more concerned about the potential tech disruptions? Let me know your thoughts down in the comments. We love hearing from you and building this community conversation. Thank you so much for watching today. If you found this video informative and interesting, please give it a thumbs up. It really helps the channel. And if you haven't already, consider subscribing and hitting that notification bell so you don't miss our future updates on Comet Atlas, the solar storms, and all the other amazing things happening in our universe. Stay curious, stay prepared, and as always, keep looking up. We'll see you in the next video. Next.